So in this video, I'll discuss the intermolecular forces of attraction or the so-called IMFA. So IMFA are forces of attraction that are strong enough to manifest through macroscopic properties. So yung mga macroscopic properties na ito yung mga na-observe natin doon sa substance. So malaking factor dito yung kanilang magiging IMFA. Okay? So for example, we have the physical state. Nalalaman natin kung magiging solid ba siya, liquid, or gas. Depende dun sa kanilang interaction through the IMFA. Okay? Pwede rin yung vapor pressure, boiling point, yung kanilang viscosity, yung kanilang surface tension, etc. So yung mga physical properties na yun, malaking factor or malaking contribution ng properties na yun ay from the IMFA. Okay? So they are strong enough to manifest through those properties, pero they are too weak to be considered chemical bonds. Of course, mas malakas pa rin talaga yung mga bonds due to orbital overlap or yung mga formal bonds like yung covalent and ionic bonds. Okay? So what are the different types of IMFA? So for the first type, we have IMFA due to instantaneous dipole interactions. So what is this instantaneous dipole interaction? So molecules undergo temporary polarization as their electron clouds approach each other. So lahat ng molecules, mapa-atom, mapa-diatomic, mapa-molecule, lahat sila meron silang tinatawag na electron cloud. Tapos yung kapit ng electron cloud doon sa nucleus, ang tawag doon ay polarizability. So kapag mahina yung kapit ng inyong electron cloud doon sa inyong nucleus, ibig sabihin weak yung interaction between the nucleus and the electron clouds, okay? Ibig sabihin mababa yung Z effective ng inyong atom or yung molecule, okay, as a whole. So ang mangyayari, mahina lang yung kapit niya doon sa kanyang mga electrons kapag nag-interact yung electron cloud sa external charge or sa kapwa niya electron clouds, napopolarize siya. So the degree of polarization depends on the number of electrons present dun sa ating molecule or atom. Tapos, yung ease of polarization naman or kung gaano kadali siya ma-polarize, nakadepende yun sa nature ng mga atoms doon sa inyong molecule. So, if you have two atoms, here and here, so as they approach each other, so represented siya ng arrow na yan, kapag naglapit sila sa isa't isa, napopolarize yung inyong mga electron clouds. So, ganyan yung nangyayari pag napopolarize. So, since napolarize to, napunta sa isang side yung partially positive charge. Kasi yung nucleus mo, napunta sa isang side. Tapos, na-sway yung mga electron clouds mo sa other side naman ng inyong atom. Okay? So, nandito ngayon yung negative charge or yung partial negative charge. So, kung na-polarize yung isang atom, mapopolarize din yung kabilang atom. So, nagkakaroon din siya ng partially positive at partially negative side. Okay? So, this polarization is temporary. Siyempre, hindi siya naglalast. Kapag naglayo na yung dalawang molecules na yan, babalik na siya dun sa kanyang initial state, okay? Which is yung uniform na charge distribution. So, since this is temporary polarization, this type of interaction is actually temporary or very weak. Okay? This is the weakest type of IMFA. So, the resulting interaction is known as the London dispersion force. Okay? Ang tawag dyan ay London dispersion force or yung van der Waals interaction. So lahat ng molecules and lahat ng atoms ay may van der Waals interaction or London dispersion force kasi lahat naman sila ay may electron clouds. Yung degree lang ng ating London dispersion force or van der Waals interaction yung nag-iiba. Okay? So malalaman nyo na dito na kapag mas mataas yung polarizability ng inyong atom or molecule, mas mataas yung degree ng polarization. Therefore, mas mataas yung London dispersion force. Okay? So here we have some notes on the London dispersion force or the van der Waals interaction. So as long as there is electron density, there is LDF. So lahat ng molecules ay nag-exhibit ng LDF, pero varying yung kanilang degrees depende again doon sa kanilang polarizability or yung sa polarizability ng inyong mga atoms. Okay? So more electrons, more density to polarize. So syempre kapag mataas yung inyong electron count or maraming electrons sa inyong system, kapag na-polarize yun, mataas yung degree kasi mataas yung degree ng negative charge sa isang side, tapos mataas din yung degree ng positive charge sa isang side. So yung degree ng polarization mas mataas pag mas maraming electrons and pag mas marami yung protons. So actually, the London dispersion force generally increases with increasing molar mass. Kasi kapag mas mataas yung molar mass ng iyong atom, for example, mas marami siyang protons and mas marami siyang electrons. So yung degree of polarization niya, kapag na-polarize siya, mas mataas. Okay? So increase in the molar mass generally increases LDF. So increase in the size and polarizability generally improves LDF. So again, polarizability and LDF are directly proportional. So kapag mas madali siyang i-polarize, mas mataas ang kanyang LDF, okay, or yung kanyang van der Waals interaction. So for example, we have the fluorine, chlorine, bromine, and iodine diatomics. So sila yung mga halides na diatomic. Okay? So mapapansin natin na yung iodine ay isang solid, yung bromine ay liquid, yung chlorine at yung fluorine ay gases. Okay? So puro sila non-polar compounds kasi yung mga geometries nila and their polarities according to the Lewis structure, okay, wala silang net dipole moment. So, ibig sabihin, lahat sila ay non-polar. Nag-iiba lang yung kanilang London dispersion force. So, ibig sabihin, yung kanilang physical state, okay, ay depende dun sa LDF. So, condensed yung ating iodine. So, ibig sabihin, pinakamataas ang London dispersion force between iodine molecules. Sumunod doon ang bromine. Liquid ang bromine. So, mas condensed ang solids kaysa sa liquids. So, therefore, mas mataas ang IMFA ng iodine sa bromine. Sumunod yung chlorine and fluorine. So, hindi masyadong madidistinguish through this physical state yung kanilang LDF. Pero, if we consider the molar mass, we can predict that the chlorine gas has more LDF than fluorine gas. So, mas strong ang LDF ng chlorine kaysa sa fluorine due to the molar mass. Okay? We can say that kasi yun yung trend. So, all non-polar yung kanilang substances but different physical states. So, na-discuss ko na to. Nag-increase ang molar mass, therefore, nag-increase din yung LDF, pinaka-mabigat yung iodine. At according to the periodic trends, yung iodine yung may pinakamataas na polarizability din. Okay? So, as you go down the group, nag-increase yung size and polarizability ng inyong element or yung inyong atom. So, iodine also has the greatest polarizability. So, combine nyo yung effect ng molar mass, tsaka polarizability, tsaka size, pinakamataas ang LDF ng iodine. So, lower ang kanilang Z effective, okay, as you go from fluorine to iodine. Tapos, nag-i-increase yung LDF strength at 298 Kelvin. So, kapag magko-compare kayo ng substances, make sure that yung temperature nyo ay constant. Okay? Para may comparable kayo or ma-compare nyo yung dalawang IMFA. Kasi IMFA changes with changing temperature. So, nag-i-increase ang temperature, humihina yung IMFA kasi tumataas yung kinetic energy. So, i-discuss ko yan sa thermodynamics. Okay? Also, increase in the surface area improves LDF. Siyempre, kapag mas mataas yung degree of interaction between the instantaneous dipoles, mas mataas yung magiging LDF nyo or magiging stronger yung inyong interaction. So, dapat mataas yung surface area of contact. Okay? So, kumataas ang surface area of contact kapag bumababa yung branching between organic compounds. So, makikita nyo dito, puro sila C5H12, pero ito ay chain. So, straight chain siya. Ito ay may isang branch, yung isang CH3 group niya ay naka-branch. Tapos dito, yung dalawang CH3 group niya ay naka-branch. Puro sila C5H12, pero mas branched si neopentane kaysa kay isopentane, tapos mas branched si isopentane kaysa kay n-pentane. So, since pinaka-branched si neopentane, pinakamababa yung kanyang surface area. Kasi, upon interaction, makikita natin dito na meron siyang quaternary carbon. Okay? Yung quaternary carbon na to mahihirapang mag-interact sa ibang or sa ibang substances o outside this molecule. Okay? So, kapag sa ibang molecule, hindi niya usually nakikita yung quaternary carbon kasi tagong-tago siya dun sa structure. Ganon din yung tertiary carbon dito. Okay? Medyo tago siya dun sa structure so hindi siya nakakapag-interact with the outside environment. Mahihirapan yung mga other molecules na makipag-interact dyan sa center ng molecule na yan or dyan sa ating tertiary carbon. However, dito sa chain, secondary carbons and primary carbons lang. So, mas effective yung interaction dito. Okay? So, therefore, we can predict that n-pentane has the strongest London dispersion force. Sumunod si isopentane. And finally, we have the neopentane, which has the weakest IMFA among the three. We should take note that the London dispersion force of cyclic hydrocarbons are generally greater than their straight chain counterparts. Okay? So makikita natin dito sa example, meron tayong cyclohexane, N-hexane, and 2,3-dimethylbutane. Pare-pareho silang may 6 carbons. So comparable lang yung kanilang molar mass. Actually, ang pinagkaiba lang ng cyclohexane dito sa dalawa, yung sa N-hexane tsaka sa 2,3-dimethylbutane ay dalawang hydrogens lang. Okay? So, this is C6H12, this is C6H14, and this is C6H14. So, halos pare-pareho lang naman sila ng molar mass dahil dalawang hydrogens lang yung pinagkaiba nila. Okay? So, makikita natin na I put here na mas mataas ang IMFA ng cyclohexane kaysa sa N-hexane. Dito, mas obvious, mas mataas ang IMFA ng N-hexane kaysa sa 2,3-dimethylbutane because of the branching. Okay? Alam naman natin to na, again, mas mahirap ma-approach yung mga tertiary carbons from the outside dahil tago sila sa structure. So therefore, bumababa ang surface area nila kapag mataas ang branching. So sa N-hexane, change siya. So okay yon. So between these two, okay, makikita natin na yung cyclohexane yung mas mataas ang IMFA. Hindi ito dahil sa surface area, dahil sa degree of freedom. So mas mataas ang degree of freedom ng mga chain hydrocarbons. Pwede mo kasi silang lukutin. Okay? Marami silang pwedeng forms. Pwede siyang straight lang na chain, pwede siyang magkaroon ng ganyang structure, yung zigzag, and other forms. Mas mataas ang degree of freedom niya. Kapag naging ring na siya, nalilimit yung degree of freedom niya. Okay? So, for cyclohexane, i-discuss ko sa organic chemistry yung mga forms ng cyclohexane. Tapos, yun lang yung actually, yung mga stable forms niya. Okay? Limited yung movement ng mga carbons, kumbaga, sa cyclohexane compared sa N-hexane. Therefore, na-maintain ng cyclohexane yung kanyang surface area. May mga times kasi na yung N-hexane, for example, ano siya, nalukot siya, kumbaga. Bumababa yung surface area niya at times. Kumbaga yung linear structure na yan yung maximize yung surface area. Pero may mga form siya na mas mababa yung surface area. Sa cyclohexane, maintained yung kanyang surface area kasi sa limited movement between the carbon atoms. Kaya mas mataas ang IMFA palagi ng cyclohexane kaysa sa N-hexane. Okay? IMFA can also manifest through interaction between compounds with permanent dipoles. So kapag permanent na yung dipole mo, yung molecule mo meron na siyang net dipole moment. Okay? Polar na ang iyong molecule. So for example, we have here HCl. Since magkaiba yung electronegativity values ng H at Cl according to the Pauling scale, may makikita natin dito na yung molecule ay polar na or meron siyang net dipole moment. So yung HCl kahit mag-isa lang siya, hindi nawawala yung kanyang dipole moment or yung net dipole moment niya. So kapag nag-interact siya with another HCl molecule, that is a dipole-dipole interaction. Hindi na siya LDF. Kasi yung sa LDF, nagpo-form lang yung inyong dipoles kapag nag-interact sila or naglalapit yung inyong mga molecules. Dito, okay, dipoles na sila to begin with. So kapag nag-interact sila, it's a dipole-dipole interaction. Okay? So nag-interact yung partially positive side sa partially negative side. So partially negative side yung inyong chlorine kasi siya yung mas mataas ang electronegativity, tapos partially positive naman yung hydrogen. Okay? So that is how a dipole-dipole interaction happens. So dito naman sa formaldehyde, partially positive yung inyong carbon dyan. Okay? Although partially positive din yung inyong mga hydrogens dyan. Tapos pwede rin mag-interact yung oxygen nyo or yung partially negative side ng inyong dipole dun sa mga hydrogens. Pero pinakita ko lang dito na nag-interact siya dun sa carbon. Kasi mas electropositive yung carbon actually dito dahil kinihila siya directly nung oxygen, which is the more electronegative atom dun sa structure. Okay? So for compounds of similar mass, the strength of the dipolar interaction or the dipole-dipole interaction depends on the difference in the electronegativities of the bonded atoms. So syempre kapag mas mataas yung delta En or yung change in the electronegativity between your atoms dun sa isang molecule, mas mataas yung inyong dipole-dipole interaction. Again, hindi siya per bond ang gagawin nyo. Okay? So ang observation nyo dito dapat ay for the whole molecule. Kasi hindi lahat ng molecules na may polar bonds ay polar. So, diniscuss ko na ito sa geometry and polarity. So, may mga polar ang bonds like CO2. Okay? So, mapapansin nyo yung CO2, mayroon siyang polar CO bonds. Pero, nagka-cancel yung dipoles nila or yung dipole moments nila. So, yung CO2 molecule, wala siyang net dipole moment. So, therefore, CO2 is effectively a non-polar molecule. Okay? So, dapat polar yung inyong molecule. Meron siyang net dipole moment. So, increase in the change in the electronegativity or yung strength ng inyong net dipole moment increases the dipole-dipole interaction. So, for example, we have here, okay, methane. So, yung methane nyo, non-polar yan kasi nagka-cancel yung mga CH bonds. And the CH bond itself is not very polar. So, ang change in the electronegativity nito, nakita natin dun sa video na nakaraan, ay 0.4 lang according to the Pauling scale. So, it's borderline non-polar. Hindi na ganun ka-polar ang CH bond. So, i-compare natin siya sa phosphine, okay, which has pH bonds, okay? Tapos meron siyang net dipole moment, tapos yung SH bonds, diktat na yan, SH bonds, okay, na merong net dipole moment din. So, polar yung hydrogen or dihydrogen sulfide tsaka yung phosphine. Pero mas mataas ang boiling point ng dihydrogen sulfide kaysa sa phosphine. Okay? So, mas mataas kasi yung change in the electronegativity between the sulfur and the hydrogen. So, sa periodic table, mas mataas ang electronegativity ni sulfur kaysa kay phosphorus. So, therefore, mas mataas or mas malakas ang dipole moment ng SH kaysa sa pH bonds. Okay? So, yung net dipole moment ng H2S ay mas malakas kaysa sa pH3. Okay? So, makikita nyo yan to the boiling point. So, makikita nyo rin na yung phosphine and dihydrogen sulfide halos comparable naman yung kanilang molar mass. So, in terms of the LDF, halos pareho lang dapat sila. Yung methane mo, magaan. Okay? Tapos, mababa talaga ang kanyang boiling point kasi bukod sa non-polar na siya, magaan pa si carbon. Or yung magaan yung buong CH4 molecule. Okay? So, a very strong and special type of dipole-dipole interaction is called the hydrogen bonding. So, yung hydrogen bonding, special type siya ng dipole-dipole interaction kasi nag-occur lang siya through certain bonds or through certain groups sa inyong molecule. So, kapag merong ganong group yung inyong molecule, meron siyang hydrogen bonding. Ano yung mga groups na yon? So, yung mga groups na yon ay yung N, O, tsaka F, tapos yung NH, OH, tsaka FH bonds. So, makikita nyo sa ibang literature na meron ding hydrogen bonding between other groups. Pero ito yung strongest hydrogen bonding groups. Okay? So, This is a very strong type of dipole-dipole interaction. So, paano nangyayari yung hydrogen bonding? So, para lang din siyang dipole-dipole interaction, mag-interact din yung partially positive sa partially negative, but the resulting interaction is very strong. So, for example, sa water, nag-hydrogen bond yung partially positive side ng water, which is the hydrogen, doon sa inyong oxygen, which is the partially negative side of your water. Pero this time, meron na tayong tinatawag na hydrogen bonding donor, which is this one, yung hydrogen, tapos yung hydrogen bonding acceptor, which is the lone pair of oxygen. So, donor-acceptor interaction ang tawag dyan. So, instead of interaction between your net dipole moments, nag-interact directly yung hydrogen dun sa lone pairs ng inyong oxygen. Okay? So, kapag sa ammonia naman, kapag nag-interact yung mga molecules ng ammonia, yung partially positive side, which is the hydrogen of the ammonia, is the donor. Tapos acceptor, yung lone pair ng inyong ammonia. Sa hydrogen fluoride naman, or sa hydrofluoric acid kapag nasa water siya, hydrogen fluoride siya kapag gas. So, that's the donor side, yung hydrogen ng inyong hydrogen fluoride. Tapos acceptor naman yung lone pair ng inyong fluorine. Okay? So, that is hydrogen bonding. Siyempre, hindi lahat ng molecules nyo merong OH, NH, tsaka FH. So, pwede natin silang i-classify. So, ano yung dalawang classification na yun? So, meron tayong polar protic substances. So, polar protic substances contain both H bond donor and acceptor. So, basically, meron lang silang NH, FH, tsaka OH bond. Kasi yung hydrogen doon, yun yung donor. Yung oxygen, o yung nitrogen, or yung fluorine, yun yung acceptor. So, kung meron kang both, okay, kung yung meron kang hydrogen na nakatouch sa oxygen, nitrogen, and fluorine, so meron kang donor tsaka acceptor groups. So, yung water, meron siyang donor group, yung hydrogens ng water, tapos meron siyang acceptor, yung lone pairs ng oxygen. So, ganun din sa ammonia, donor yung hydrogens niya, tapos yung lone pair niya yung acceptor. Sa hydrogen fluoride, yung lone pairs yung acceptor, tapos ito yung donor, yung hydrogen. Pwede ka rin magkaroon ng nitrogen, oxygen, and fluorine, pero walang OH, NH, or FH bonds. Ang tawag doon ay polar aprotic substances. So, polar aprotic kasi acceptor lang ang meron sila. So, for example, we have here the formaldehyde. Yung formaldehyde, wala siyang OH bond. Meron lang siyang oxygen. So, yung oxygen, capable siya of accepting hydrogen bonds kasi meron siyang acceptor group, yung oxygen. Yung tertiary amines naman, like this one, okay, wala siyang NH bond. So, acceptor lang din ang meron siya. So, sa fluorine, or this is fluorocyclohexane, okay, meron siyang acceptor pero wala siyang donor kasi walang FH bond. Sa case ng HF lang talaga yung hydrogen bonding ng fluorine na may donor. Kasi the rest, wala na siya. Kasi isa lang naman ang pwedeng hydrogen na ma-accept ng fluorine through the covalent bond. Okay? Siya lang yung usual na nag-exist. Okay? So, compounds with H bond donors can exhibit H bonding in their pure state. Siyempre, kung may donor at acceptor ka, makakapag-H bond ka with yourself. Okay? So, yung water, nakakapag-H bond siya with other water molecules. Yung ammonia, ganun din, pati yung HF. Pero kapag acceptor lang ang meron ka, kapag ka pure state, ibig sabihin, for example, puro formaldehyde lang, dipole-dipole interaction lang yon. Dipole-dipole interaction lang din ito kasi wala siyang NH group. So, in the pure state, or kapag puro ito lang yung molecule mo dun sa system, dipole-dipole interaction lang siya. Pero for example, dun sa formaldehyde, nag-add ka ng water, nagkakaroon ka na ng H bond donor. So, yung H bond donor ng water mo, which is the hydrogen, mag-i-interact siya dun sa oxygen na ito ng inyong formaldehyde. Okay? So, tataas yung IMFA kasi meron ng hydrogen bonding dun sa system kapag nag-add ka ng water dun sa formaldehyde. Ganon din dito. Kapag nag-add ka ng ammonia or water dyan, nagkakaroon din ng H bonding due to the H bond donors of your ammonia and yung water. So, tumataas din yung IMFA ng system pag nag-add ka ng donor. Okay? So, compounds without H bond donors only exhibit typical DDI or dipole-dipole interaction in their pure state. Okay? So, we have here some examples of hydrogen bonding structures. So, makikita nyo, may hydrogen bonding dyan. That's a donor-acceptor interaction. Okay, meron din dito, dito, at dito. So, per lone pair, meron kang isang hydrogen bonding acceptor na region or site. Okay? So, since may dalawang lone pairs yung inyong water, may dalawa siyang H-bond acceptor sites. Yung water, meron din siyang dalawang hydrogens, so meron siyang dalawang H-bond donor sites. So, in total, yung water molecule mo, meron siyang 4 na hydrogen bonding participants. Dalawang acceptor at dalawang donor. Sa formaldehyde, dipole-dipole lang siya in the pure state, so ganito lang yung interaction niya, pero meron siyang dalawang H-bond acceptor sites. So, water and ammonia naman yung nandito. So, yung ammonia, meron siyang 3 H-bond donor sites at isang H-bond acceptor site. Yung water may tig-2, acceptor and donor. So, itong ammonia na to, isang acceptor, 3 donors. Okay, so ganyan yung H-bond structure ng water tsaka ng ammonia. Kaya, nagmi-mix sila sa solution. Okay? So again, i-count natin. So this is counting H-bond participants. Each lone pair is an H-bond acceptor site, and each hydrogen na nakakabit sa nitrogen, oxygen, or fluorine is a donor site. Okay? So yung ammonia, meron siyang 3 donors at isang acceptor. Yung amine na ito, okay, this is ethylamine, meron siyang dalawang H-bond donor at isang acceptor. And this tertiary amine has 1 H-bond acceptor. Tapos wala na siyang H-bond donor kasi wala siyang NH bond. So sa water, makikita natin dito, okay, tig-dalawa yung acceptors and donor niya. So kapag alcohols na, okay, makikita natin na dalawa pa rin yung acceptor pero isa na lang yung donor group. Tapos kapag ethers na, puro acceptors na lang, wala na siyang donors kasi wala na siyang OH bond. Okay? So again, we have H bond structures right here. So halimbawa sa dalawang carboxylic acid, yung donor group ng inyong carboxylic acid, which is the hydrogen attached to your oxygen, yun yung nag-interact dun sa carbonyl oxygen dyan. Okay, ganun din dito. So, mataas yung interaction between carboxylic acid molecules kasi meron siyang ganyang klase ng structure. So, yung inyong acetic acid, for example, nagpo-form siya ng dimers kapag ka gaseous state. So, kapag nag-evaporate yung inyong acetic acid, nagpo-form siya ng ganitong dimer. Okay? Mataas na interaction between inyong carboxylic acid groups. Okay? So, yung ammonia, ganun din, meron siyang hydrogen bonds. Hindi naman nagpo-form ito ng ganyang klase ng molecule sa gaseous state kasi ito ay weak interaction lang compared dun sa oxygen, pero meron siyang hydrogen bonding. So, yung inyong acetone and water, so that's why yung acetone nilalagyan nyo siya ng water para hindi siya mag-evaporate agad. Kasi yung acetone nyo, meron lang siyang H-bond acceptor. So, mahina ang interaction between acetone molecules. So, you put water in the acetone solution para ma-maintain mo yung concentration ng acetone mo dun sa system. So, paano nyo yung na-maintain yun? Kasi meron ng hydrogen bonding. Okay? Acetone has an oxygen that can accept hydrogen bonds. So, may donor group yung inyong water. So, nagkakaroon ng increase in the interaction pag naglagay ka ng water sa acetone. Okay? So some notes on hydrogen bonding. Groups with H-bond donors generally have higher boiling points or they have significantly higher boiling points. Mas matataas ang boiling points ng mga molecules na may H-bond donors kaysa dun sa H-bond acceptor lang. So for example, we have N-butanol and butanal. So butanal is an aldehyde, N-butanol is an alcohol. So yung alcohols meron siyang OH group, therefore meron siyang donor and acceptor groups. Yung butanal wala siyang OH group, puro lang siya H-bond acceptor. So mas mataas ang boiling point ng N-butanol kaysa sa butanal. Okay? So, yung butanal, kapag nilagyan mo siya ng H-bond donor, like water, nag-i-increase yung boiling point ng inyong system. Yun yung effect kapag nagkakaroon ka ng hydrogen bond. So, between butanal molecules, dipole-dipole lang ang interaction, tsaka LDF. Okay? So, for the next one, decrease in the number of H-bond donors/acceptors decreases the boiling point given comparable mass. So for example, we have here a primary amine. Okay? Yung primary amine nyo, meron siyang dalawang H-bond donor at isang acceptor. Tapos meron kang secondary amine dito. Pareho lang sila ng mass kasi pareho sila ng number of carbons. 1, 2, 3, 4. 1, 2, 3, 4. 4 carbons din yan. So, ito ay secondary amine. Ito ay primary amine. So, yung primary amine, meron siyang dalawang H-bond donor groups. Yung secondary amine, meron siyang isa lang. At isang H-bond acceptor. So, ito yung comparison, 2 H-bond donors, 1 H-bond donor, pareho sila ng acceptors, okay? Pero mas mataas yung boiling point ng primary amine kaysa dun sa secondary amine due to the number of H-bond donors present. So, mas konti yung H-bond donor groups nitong molecule na to kaysa dito, so mas mataas ang boiling point nito. Okay? So now we have here the ion-dipole interaction. So from the name itself, interaction siya ng isang neutral polar molecule with a charged species. So for example, we have here water, tapos NaCl. Yung water, siya yung neutral polar molecule. Meron siyang hydrogen bonding, so mataas ang kanyang IMFA. Tapos we have here NaCl. Okay? Yung NaCl ay ionic compound. So kapag ka naglagay ka ng NaCl sa water, so yung water dito yung parang solvent natin. Tapos yung NaCl yung solute. Okay? So magkakaroon ka ng ion-dipole interaction right here. So yung cation, yung Na+, nag-interact siya dun sa electron-negative side. Okay? Tapos yung chloride, nag-interact siya dun sa partially positive side or yung electropositive side. Okay? So now let's compare the degree of ion-dipole interaction between different types of molecules. Yung may hydrogen bonding donor acceptor, yung may hydrogen bonding acceptor lang, tapos yung simple polar molecules lang. Okay? So molecules with H-bond donor groups are effective towards ion-dipole interaction. Actually, they are the most effective towards this type of interaction. So for example, we have here alcohols, okay, yung ethanol natin, tsaka yung ammonia. So they are polar protic solvents. They both have the H-bond and donor and acceptor. So, they can stabilize both the cation and an ion effectively. Kasi, okay, mataas yung degree ng kanilang dipole moment or mataas yung magnitude. So, very electropositive si hydrogen, very electronegative si nitrogen. So, na-stabilize nung partially negative group yung cation at na-stabilize nung partially positive side yung cation. Ganon din dito sa alcohol. Okay? So, pagdating naman dito sa polar aprotic solvent, they are compounds with H-bond acceptor pero wala silang H-bond donor. Hindi nila masyadong na-stabilize yung anion. Bakit? So for example, we have here yung acetone. So sa acetone, very electronegative si oxygen. So kayang-kaya niyang makipag-interact with Na+. However, hindi masyadong electropositive si carbon. So hindi niya masyadong nakaka-interact or hindi masyadong effective yung interaction niya with the chloride. So ang nangyayari dito, hindi masyadong effective yung overall interaction. So kung ikaw yung NaCl, okay, mas effective na mag-bind na lang yung Na+ tsaka Cl- kasi mas strong yung interaction nun. Okay? So if NaCl is the solute and acetone is the solvent, mas mataas yung interaction between solutes. Yung solute-solute interaction nyo, mas mataas kaysa sa solute-solvent interaction na ito. So ibig sabihin, hindi na di-dissolve si NaCl ng acetone. Okay? Ganon din dito sa ether na to. Hindi masyadong nadi-dissolve or hindi actually nadi-dissolve talaga ng ether yung NaCl. Kasi, again, hindi ganun ka-effective yung interaction ng partially positive group doon sa inyong anion. Okay? Lalo na pagka dito tayo sa simple polar molecules. Polar aprotic din naman sila. Wala rin silang hydrogen bonding donors. Pero hindi rin sila hydrogen bonding acceptors. Okay? Hindi sila nitrogen, oxygen, or fluorine. So, lalong mas mahina yung interaction between the solvent molecule and the ionic species which is the solute. Okay? So, hindi na di-dissolve si NaCl dito sa molecule na ito. Sa alkyl halide na to. At hindi rin nadi-dissolve si NaCl dito sa hydrogen or sa dihydrogen sulfide kasi masyadong mahina yung solvent-solute interaction. Okay? Mas pinaprefer na lang ng sodium chloride na mag-clump na lang sila kasi mas mataas yung ionic interaction. Okay? So let's talk about water and why is it called a universal solvent. So for the first reason, it is the strongest H-bonding liquid at 25 degrees Celsius. So dito, kino-compare natin yung nitrogen, oxygen, and fluorine. So for nitrogen, oxygen, and fluorine compounds, itong tatlo yung may maximum number of H-bonding donors. Okay? So for a nitrogen compound, tatlo yung maximum. That is the ammonia molecule. So for a fluorine compound, FH yung may pinakamaraming H-bond donors. So other molecules of nitrogen, oxygen, and fluorine have less number of H-bond donors. Kasi, for example, yung sa nitrogen compounds, yung mga amines, it has less than 3 H-bond donors. Yung mga alcohols and ethers, they have less than 2 hydrogen bonding donors. Yung mga fluorine compounds, wala na silang H-bond donors. Kasi yung fluorine atom, okay, sa isang atom lang din siya kumakabit due to the number of lone pairs of or the number of electrons around fluorine. Isa lang yung available for covalent bonding. So kung i-compare natin yung tatlo, yung ammonia and fluorine, okay, relatively strong ang kanilang H bonding pero sila ay gases. Water lang yung liquid sa tatlong yan. Okay? So it is also a small molecule, yung water, which makes it effective in stabilizing even large polar molecules. So, na-stabilize din ng water sa solution or sa solvent system yung mga malalaking biomolecules like yung monosaccharides and sometimes yung disaccharides. So, naihahalo nyo yung sucrose sa tubig due to the strong hydrogen bonding between the sucrose hydroxyl groups and yung water. Tapos yung water, small molecule pa siya. So, madali siyang nakakapasok dun sa inyong sucrose molecules para mag-interact dun sa kanyang mga hydroxyl groups. So, ganun din sa mga amino acids. Okay? So, mataas ang interaction sa mga amino acids. Kaya yung mga ibang polypeptides and some amino acids, they are water soluble. Okay? Kaya sa ating bodily systems or sa ating katawan, marami tayong water. Okay? Para makapag-perform tayo ng mga biological processes. Kasi water is the only substance known na nakapag-stabilize ng mga biomolecules na to in solution. Siyempre, hindi kasama dito yung lipids. Okay? Kasi yung lipids non-polar sila. Okay? So meron silang kakaibang ginagampanan dun sa ating body. So not necessarily in solution or in water. So dinadala sila minsan ng ating mga other biomolecules para ma-deliver yung kanilang function sa ating biochemical systems. Okay? So what are the consequences or effects of having a strong or a stronger IMFA? Okay? So for the first one, your boiling point increases. So mas mataas ang boiling points ng mga compounds na mas mataas ang IMFA. So boiling point is the temperature at which the liquid and gaseous states of a certain compound coexist in the system. Okay? So for example, you have liquid water. Kapag nag-add ka ng heat of vaporization, okay, na-evaporate mo yung water into water vapor. So, yung vaporization ng ating water ay at 100 degrees Celsius and 1 atm. So, that's the normal boiling point. So, yung normal, Okay, ang ibig sabihin ng normal, yung 1 atm. Okay? So, your normal boiling point is your boiling point at 1 atm. Okay? So, boiling or evaporation is endothermic. So, nagre-require siya ng energy para mag-occur. So, yung boiling ng water is endothermic. Yung condensation naman ng water, yung reverse ng process na ito, ay exothermic. Okay? So, delta VAP H is the heat of vaporization. So, that's the heat required to evaporate a liquid. This is also the heat released, okay, kapag ka yung gas mo ay nagko-condense, yung gas mo nagiging liquid. Okay? So, stronger IMFA means more heat of vaporization required for the forward process. So, kapag mataas ang IMFA mo, nag-i-increase yung heat required para ma-evaporate mo yung substances. Okay? So another effect is the decrease in the vapor pressure. So vapor pressure and boiling are related. Kasi yung vapor pressure, ito yung pressure ng iyong gases above the liquid. So vapor pressure is the pressure exerted by the gas molecules that escapes the solid or the liquid phase. So sa example natin, if we have a liquid, may mga molecules na tumatakas doon sa liquid state, nagiging gas sila. Tapos kung meron tayong wall, okay, nagbabangga sila dun sa wall. Tapos yung force of interaction nila dun sa wall, yun yung tinatawag nating vapor pressure. Okay? So, related siya sa boiling point kasi to be able to convert your particles from the liquid to the gaseous phase, nag-absorb siya ng either vaporization or sublimation enthalpy. Yung sublimation enthalpy, that's for solid to gas transformation. Yung vaporization is for liquid to gas transformation. So, yun yung mga individual energies na ina-absorb muna ng molecule nyo or nung atoms nyo bago siya nagiging gaseous phase. So, hindi ganun karami yung energy na yan kapag below the boiling point, okay, or the sublimation point. So, nagkakaroon ka lang ng konting amount of gas particles. So, the escape is due to the absorption of energy of individual atoms but only at a very low degree, especially at temperatures way below the boiling point or the sublimation point. So, nag-exist lang sila as gases tapos konti lang yung amount nila dun sa system. Kasi hindi pa nare-reach nung substance na yon yung boiling point. Kapag boiling point, halos lahat sila pwede na mag-escape, kumbaga. Okay? So, delta sub H is the heat of sublimation, okay? That's the heat required to convert a solid to a gas. That's also the heat released kapag yung gas mo nako-convert sa solid. Okay? Kapag ka-reverse yung iyong reaction. Okay? So, increase in the IMFA increases both these energies. So, it makes it more difficult for the molecules to escape. So, ang nangyayari, bumababa yung vapor pressure kapag ka nag-i-increase yung IMFA. So, therefore, we have this one. So, decrease in the vapor pressure kapag ka stronger ang IMFA. So, for the next property, kapag strong ang iyong IMFA, you have an increase in the surface tension. So, ano yung surface tension? Okay? Kapag meron kang liquid, meron siyang dalawang regions. Yung bulk phase, yung nasa gitna, okay, ng iyong liquid, and yung surface. Okay? So, in the bulk region, IMFA is present in all directions, which results in a zero net force. So, kung makikita niyo yung molecule na to, yung mga arrows na yan, it represents the force it exerts with other molecules. So, since nasa gitna siya, okay, lahat ng mga katabi niyang molecules nag-exert ng IMFA. So, nakakancel yung mga forces na yun. Okay? So, yung net force na nararamdaman ng molecule dyan is basically zero. Pero kapag nasa surface ka na, okay, the forces are not balanced kasi wala siyang molecules na nakaka-interact above its surface. Okay? So, meron pero nasa gaseous phase kasi vapor pressure pero hindi yun malakas. So, ang nangyayari, okay, since unbalanced yung force doon sa surface, nagkakaroon ka ng net inward force. So, kapag inad nyo tong vectors na nandito, okay, that's a net inward force. Okay? So, meron kang force sa left at meron kang force sa right. So, nagka-cancel yung dalawang yan. Pero walang nagka-cancel doon sa downward force. So, nagkakaroon ka ng net inward force from the surface. So, gusto nung iyong liquid or yung particle dyan sa surface na pumasok doon sa bulk phase kasi nandun yung force. Okay? So, that is the surface tension. That's the net inward force. So, mas mataas ang surface tension kapag malakas ang IMFA. Of course, kasi mas malakas yung vector na ito. So, since mataas yung interaction, mas nahihila ng mga bulk particles, yung mga particles na nasa surface. Okay? So, for number 4, if we have stronger IMFA, we also have an increase in the viscosity. So, ano yung viscosity? Viscosity is the measure of the fluid's resistance to flow. So, habang nagfo-flow yung molecules, syempre, nag-exert siya ng IMFA with other molecules. So, that force, okay, results to friction. So, nagkakaroon ng friction kasi nagkakaroon ka ng relative motion. So, ano ibig sabihin ng relative motion? Kung gumagalaw kayo, okay, at hindi pantay-pantay yung speed nyo, okay, So, you are moving relative to each other. So, mas mabilis yung ibang molecules kaysa sa ibang molecules or sa the rest ng molecules. Okay? So, nagkakaroon ka ng relative motion. So, kapag may relative motion at may IMFA or kapag may friction, nagkakaroon ka ng viscosity or nagkakaroon ka ng resistance to flow. Okay? So, increase in the IMFA increases the friction. Therefore, it increases the viscosity. Okay? So let's also talk about cohesion and adhesion for liquids. Okay? So since the liquid molecules are usually different from the components of the container, so magkaiba yung composition or yung structure ng mga molecules doon sa container kung saan nakalagay yung liquid, saka doon sa molecules ng mismong liquid, okay, three possible results may happen at the surface. So kung yung liquid nyo ay may weak IMFA, especially yung mga non-polar molecules, ganito lang yung itsura ng kanilang surface. So flat lang siya. Okay? So hindi masyado nag-interact yung inyong liquid particles dun sa container, tapos mahina rin yung interaction between the liquid particles. So weak IMFA overall. So flat lang yung inyong surface. Pag may strong adhesion, ibig sabihin yung interaction between the liquid particles and yung components ng inyong container ay mataas, nagkakaroon ka ng konting elevation dun sa gilid ng inyong liquid. Okay? So yun yung tinatawag nating upper meniscus. So yung lower meniscus nasa gitna siya. Kasi umaakyat yung mga nasa gilid ng iyong liquid kasi mataas ang adhesion niya doon sa inyong container walls. Okay? Pag strong cohesion naman, ibig sabihin mas mataas yung interaction between the liquid particles kaysa dun sa interaction ng inyong particles o yung liquid particles niya dun sa container, ganito naman ang nangyayari. Okay? So, tumataas yung gitna kasi mas nagkakaroon ng clumping yung inyong particles with each other, yung liquid particles nyo. Okay? Tapos, hindi masyadong kasing lakas ng interaction ng liquid particles nyo dun sa walls ng inyong liquid container. Okay? So for this exercise, compare the following pairs of compounds based on the properties indicated below. So, kung sino yung may higher boiling point, okay, or higher boiling temperature, at kung sino yung may higher vapor pressure at 298.15 Kelvin. So, higher boiling temperature at 1 atm, yung i-compare natin. So, for number 1, we have PCl5 and SCl6. So, based on their Lewis structures, okay, malalaman natin na pareho silang non-polar. Pero mas mabigat si SCl6 kasi mas mabigat si sulfur kaysa kay phosphorus at mas maraming chlorines yung SCl6 kaysa sa PCl5. Pero pareho silang non-polar, so parehong LDF lang din ang kanilang IMFA. So mas mataas ang boiling point dapat ni SCl6 kasi siya ay may mas mataas na molar mass at mas mataas ang vapor pressure ni PCl5. Okay? So kapag mataas ang molar mass, again mataas ang LDF. So kapag mataas ang LDF, mababa din ang vapor pressure. So SCl6 has a higher boiling point than PCl5 and PCl5 has a higher vapor pressure than SCl6. So inverse lang naman ang relationship ng boiling point at vapor pressure. Pag mas mataas ang boiling point, mas mababa ang vapor pressure. Okay? So sa number 2, we have these compounds. So pareho silang 6 carbons. 1, 2, 3, 4, 5, 6. So ito ay 6 din. 1, 2, 3, 4, 5, 6. Okay? So pareho silang non-polar. So LDF pareho. Okay? So meron tayong rule again na mas mataas ang IMFA ng cyclic kaysa sa chain. So mas mataas ang boiling point ni cyclohexane kaysa kay hexane or sa N-hexane. Tapos mas mataas of course yung vapor pressure ni N-hexane kaysa kay cyclohexane. Okay? So for number 3 we have 2 amines. So 1, 2, 3, 4. 1, 2, 3, 4. So pareho lang sila halos ng molar mass. Actually pareho sila ng molar mass kasi isomers lang sila. Pero ito ay may dalawang H-bond donors. Ito ay isa lang. So meron silang LDF, okay? Kasi meron silang electron clouds pareho at meron silang H bonding. Okay? Ito rin ay LDF tsaka H bond. So kapag ka H bond yung interaction nila, kapag yun yung type ng dipole-dipole interaction, yun na lang din yung i-indicate nyo. Huwag na kayo maglagay ng dipole-dipole interaction. Okay? So, sino ang may mas mataas na boiling point? Siyempre, yung may mas maraming H bond donors. Okay? At siya rin yung mas mababa ang vapor pressure. So, for number 4, we have this compound. So, dito meron tayong NH2 na may dalawang donors. Dito meron tayong OH na may isang donor. Pero ang i-compare natin dito is not the number of donors but the strength. So, mas mataas ang strength ng IMFA or ng dipole ng ating OH kaysa sa NH. So, therefore, okay, stronger ang IMFA or stronger ang hydrogen bonding ng OH or ng molecule na nasa B or nasa column B kaysa sa column A. Okay? So, pareho lang din silang may LDF tsaka H bond. Okay? So, paste ko to. Gawin kong yan. Tapos, LDF tapos H bond. Okay? Tapos, since OH is stronger than NH in terms of the degree or in terms of the dipole moment, mas mataas ang boiling point nung nasa letter B kaysa nasa letter A. Tapos, mas mataas ang vapor pressure ni letter A kaysa kay letter B. So, finally, we have this compound. Meron tayong ester, tapos meron tayong amide. Tapos, check natin. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? So, pareho lang sila ng molar mass. Ay, ng number of carbons, I mean. Pero, nitrogen ito. Okay? So, comparable naman yung kanilang IMFA actually. Pinagkaiba lang nila ay mass. Okay? So, ang unahin natin ay yung ester in terms of the strength. Kasi, parehong oxygen siya. Mas mabigat ang oxygen kaysa sa nitrogen. So, for these compounds, pareho silang LBF. Okay? Pero since sila ay walang NH or OH groups, pareho lang silang dipole-dipole interaction. Okay? Yeah. So, yan lang yung mga interactions present dyan sa dalawang compound. So, i-consider na lang natin dito yung molar mass. Kasi pareho lang silang parang walang hydrogen bonding. Ang pinakaiba lang nila ay mass. Tapos yung polarities nila ay hindi ganun ka-significantly different. Okay? So, mas mataas ang boiling point ng ester o yung nasa letter A compared dun sa letter B. Tapos, mas mataas ang vapor pressure nung nasa letter B compared sa letter A due to the mass. Okay? So, that's my discussion on the intermolecular forces of attraction and its consequences. So, sa susunod na video, i-discuss ko na yung thermodynamics or thermochemistry. Okay? So, see you next video.